In this module, we will look into e-commerce deployment topology. Let's take a look at what I will cover in this module. First, we will be discussing about omni-channel topology. Then we will talk about e-commerce deployment and considerations. Then further we will discuss about online store topology. I will further show you about sample topologies, where I will talk about a small form, a medium form, and further we will be discussing about high availability and performance considerations. Let's start with the omni-channel topology in the first lesson. The high level view of the omni-channel deployment topology, that includes both online and brick and mortar stores. If you see as an online channel topology, I would be covering that in this particular slide. If you look through this slide, you have the retail headquarters, which holds Microsoft Dynamics AX 2012 for retail as the backbone, connects with the online channel through commerce runtime, with the connectivity between both through CDX, async server and async client. So similarly, from retail headquarters, you will have the topology on a high level view for a POS terminal to connect with retail headquarters through CDX. So moving on to the next slide, here this is all about enterprise level environment, where you have multiple locations of online channel to be configured for our online store. So depending on the business requirements for the e-commerce solution, the deployment may include several data centers, for example located in different geographies such as Americas, Europe and Asia. The deployment topology with multiple online store data center is shown in this diagram. So again, here if you look at each and everything of different data centers hold its own commerce runtime, and they connect through CDX to the retail headquarters. Again, this is a very high level view of how a e-commerce deployment will happen. Okay, so now let's move on to the next topic of discussion in the next lesson, where I will be discussing about e-commerce infrastructure architecture. The logical infrastructure architecture and the main server roles for the e-commerce solution implementation are illustrated as shown in this diagram. The infrastructure architecture diagram shows the Microsoft Dynamics AX 2012 for retail components for the head office and the SharePoint Server 2013 form for the online storefront. Moving on, if you see here with the retail headquarters, you have a SQL Server AX database, which stays as the database for AX, and a AOS server which will be configured, and an CDX machine which is nothing but async server which will be configured, and also a real time service website will be configured in the retail headquarters. So this would be the part of retail headquarters in the infrastructure front. And in the other end, if you look at the SharePoint farm, you will be having a separate dedicated database where the channel DB will be sitting for CRT, and then you will have the SharePoint databases which will have the site collection datas, and then also we will be holding the product catalog site collection data here in the database. And here if you notice, we have a SharePoint front end commerce runtime and a SharePoint back end commerce runtime, which means you have a application server and a front end server. So the front end server will be the one which will be consumed by the consumers when they try to do any request to the SharePoint server on the online store. And similarly, if any indexing, the search processes and any application like metadata service, all those services will be running in the application server. So by which you will have both these activities happening separately, and you will have a good bandwidth for the consumers to connect to your web storefront server. But in a typical farm environment, always you may be having multiple application servers to share the load between the services like search service and metadata service, and this is more of a e-commerce infrastructure architecture. It depends on scenario to scenario to extend more application servers in SharePoint, similarly more web front-end servers based on the number of consumers you hold for the online store. So here if you see, there is a CDX server mentioned, which is nothing but asynchronous client service which will be running on this particular machine. So by which there will be a syncing of job from the CRT database to the SharePoint web front-end and the application server through timer jobs. So this depicts the entire e-commerce infrastructure architecture. So you must note here that Dynamics AX 2012 requires Active Directory Domain Controller, that is prerequisite for installing AX. The DC server role is not shown in the infrastructure architecture diagram that I showed you, just for simplicity. Depending on specific requirements, additional server roles might be deployed in the head office and also in the SharePoint server. This includes enterprise portal for Dynamics AX, so which is also in short called as EP. So with EP you can have a web way of configuring or adding any of the data into the AX, especially with respect to retail. So you can expose some of the forms to the EP and you can have managed in EP with a list page web parts. SQL Server reporting services and SQL Server analytics services. In short, it is also called as SSRS or SSAS. You may need that into your AX environment in order to manage some of the analytics and reporting data for the retail industry. So Microsoft SQL Server reporting services is the primary reporting platform for Microsoft Dynamics AX, and Microsoft SQL Server analysis services is a server based solution that provides functionality for online analytical processing, which is in short called as OLAP. So OLAP reports help users analyze business data and identify trends that they might not discover if they view the data in traditional reports. So let's talk a bit more about head office infrastructure considerations in the next lesson. When you deploy Microsoft Dynamics AX for e-commerce solution, you must have a good understanding of your organization and your customers and their requirements, so that you can make good decisions as you plan the solution implementation. You must carefully consider the performance requirements for your deployment during the planning stage to guarantee that the deployment is successful. This section provides you an overview of the hardware infrastructure consideration for AX deployment in the head office. So based on performance requirements, the server components in the head office support scale out options of either clustering or multi-instance. For the smaller implementations, you can also combine multiple components on the server. If you look at this slide, the first link that I have shared would be the link which will help you to understand about different planning considerations. Let me click on this link. So this is about planning system topology. You can find in TechNet about each and every topology that is expected for setting up different Microsoft products for you to have the entire storefront up and running seamlessly. So switching back to the slide. So if you see here, the transaction volume is a very key factor for planning your hardware and software components. The database server infrastructure, such as the type and number of drives, and also the number of application object servers, which is also called as AOS clusters. So it depends on how many AOS you are running for your AX to have a better performance, and also number of AOS instances in a cluster, then the number of batch servers, and what is the network capacity that you have for your transactional volume. So further, if you look at, there are a lot of transactional volume data that you will be finding between the AX and also towards SharePoint Server 2013. So the network capacity is a very key factor that we need to plan. So important one to understand would be, in Microsoft Dynamics AX, a transaction is defined as the processing of a single line item. For example, a sales order that has 100 line items is considered 100 transactions. The performance of the database can significantly affect overall Microsoft AX performance. To achieve the best performance, the SQL Server environment and storage subsystems must be configured correctly. When you consider the e-commerce transactional volume, you must estimate the number of transactions that are generated by the online store and number of any corresponding transactions that might be triggered. You also have to determine whether there are any integration points to internal or external applications. For example, a large volume of transaction may come from the integration with the logistics providers. This volume of transaction must be factored into your infrastructure and topology planning. There are several performance benchmarks available to help you with planning your hardware infrastructure. If you come back to the slide, I have a third link which talks about what is the performance benchmark that we have based on different testings which the product team did along with the release of R3. So they tried with different number of sales lines and what would be the transaction volume, and considering the different aspects that we discussed earlier with the transactional volume. So with all those considerations, they have a benchmark as a white paper available for you with at the partner source. So I will see you in the next lesson where we will discuss about online store topology. The online store is a search driven site that uses SharePoint 2013 search technology to dynamically show content. This lesson begins with the overview of search components before covering the server roles that are included in the online store topology. Then this lesson discusses the sample online store topology and hardware sizing and provides the high availability and performance consideration for planning your online store deployment. Search components. The search architecture in SharePoint 2013 contains several search components and databases. SharePoint 2013 search components are crawl component, content processing component, analytics processing component, index component, query processing component, and search administration component. First, let's talk about crawl component. The crawl component crawls the content sources. You can crawl lot of content sources, for example, file shares, product catalog, SharePoint content, and many more. To retrieve information, the crawl component connects to the content sources by invoking the appropriate indexing connector or protocol handler. After you retrieve the content, the crawl component passes crawled items to the content processing component. The content processing component processes crawled items and sends these items to the indexed component. The content processing component performs operations such as document parsing and property mapping. It also performs linguistics processing such as language detection and entity extractions. So the component transforms crawled items into artifacts that are included in the search index. The content processing component also writes information about links and URLs to the link database. Next would be the analytics processing component. Analytics processing component performs two types of analytics: search analytics and usage analytics. This component uses information from these analytics to improve search relevance, create search reports, and generate recommendations. Search analytics is about extracting information such as links, the number of times an item is clicked, anchor text, data related to people, and metadata from the link database. This information is important to relevance. Usage analytics is about how to analyze usage log information received from the front-end server through the event store. Usage analytics generates usage and statistics reports. The results from the analytics are added to the items in the search index. In addition, results from usage analytics are stored in the analytics reporting database. Next would be the index component. This receives the processed items from the content processing component and writes those items to an index file. Index files are stored on a disk in the server that hosts the index component. The index component also receives queries from the query processing component and returns result sets. You can divide the search index into discrete portions. This is known as the index partitions. The search index is the aggregation of all index partitions. Each index partition holds one or more index replicas that contain the same information. To achieve fault tolerance and redundancy, you can create additional index replicas for each index partition and distribute the index replicas over multiple servers. The index component is the logical representation of an index replica. In search topology, you have to provision one index component for each index replica. The query processing component would be the next one, which analyzes and processes queries and results. It performs linguistic processing such as word breaking and stemming. When the query processing component receives a query from the web frontend, it analyzes and processes to query the optimized precision and also to recall and relevance. The processed query is submitted to the index component. Then the index component returns a result set based on the processed query to the query processing component. This in turn processes the result set before it returns it to the web frontend server. The search administration component runs the system processes for search. This component performs provisioning, that is to add and initialize instances of the other search components. Moving on, let's talk about SharePoint 2013 search databases. As you see here, we have following components that are crawl database, link database, analytics reporting database and search administration database. So first, the crawl database. So the crawl database stores tracking information and historical information about the crawled items. For example, it stores information about the last crawl item, the last crawl ID and the type of update during the last crawl. The link database stores the information extracted by the content processing component. In addition, it stores information about search clicks, that is, the number of times people click a search result from the search result page. This information is stored unprocessed to be analyzed by the analytics processing component. The analytics processing reporting database stores the results of the usage analytics. In addition, it stores statistics information from the analysis. SharePoint uses the information to create Excel reports that shows different statistics. The search administration database stores search configuration data such as the topology, crawl rules, query rules and the mapping between crawled and the managed properties. It also stores the system access control list, which is also called as ACL, for the crawl component. There can be only one search administration database per search service application. So let's now take a look at the server roles in the online store topology and some samples of it in the next lessons. Server roles included in the online store topology are front-end SharePoint web server, SharePoint application server and database server. The front-end SharePoint web server role performs the functions that host search web parts and web part pages for answering search queries. This role can be shared with the SharePoint application server in the online store. The query processing component and index components reside on the front web server. To make maximum use of the available hardware resources and to simplify the scaling out of the search topology. It also hosts CRT, so holds a complete search index if only one index partition is configured. Otherwise, it holds part of the index that are associated with the index partitions as configured by the administrator. Consider the following plan when you plan the location and topology for search index. The query processing component routes incoming queries to index replicas. Each index replica is an index component. At least one index partition must be configured per form. Add more index replicas to increase query throughput. Add one index partition for every 10 million items in the search index. The SharePoint application server roles host all the search components and CRT if only one server is configured. Otherwise, it holds the search components associated with the server as configured by the administrator and the CRT. At least one of each search component must be configured per form. You cannot have multiple search components of the same type on one application server. To provide redundancy, you can add search components on separate servers. You can use a Windows PowerShell deploy the search components on separate SharePoint 2013 servers so that you can scale out the search topology. The database server roles host the following databases: search database, CRT database can host other SharePoint server 2013 databases also. So, the database server can be mirrored or clustered for high availability. To increase performance and capability, consider adding disks to the database server or adding database servers depending on the bottleneck. Now, let us talk about the single server and its topology. So, let us move on to this slide where we will look at sample of a single server online topology. A small form is useful to serve only limited online store deployments. A small user base, a low usage load, which means a few requests per minute up to very few requests per second, and a very fairly small volume of data. So, in short, probably around 10 or more gigabytes. The small form topology consists of two tiers, one or two servers that may combine the SharePoint 2013 server role and the communication server role. The SharePoint server hosts the search components and the commerce runtime, a single database server or cluster. Note that the commerce data exchange can be installed on one of the SharePoint server machines or on separate communication server. This diagram illustrates a simple form topology. So, if you look at this, you have an search administration component, an analytics processing component, so a crawl component, a content processing component, a index component, a query processing component, which all are part of a web front-end server, and in short, altogether this would be like a one WFE and a one SharePoint application server, which will also host CRT data calls and which may connect to a single database server wherein SharePoint DB and the CRT DB would be hosted. So, now let us move on to the talk about topology for a medium server in the next lesson. The medium form topology for the online store introduces three-tier form architecture. Let us take a look at this diagram in the PPT slide. So, if you look at here, a dedicated front-end SharePoint web server that have the index component and the query processing component, a dedicated backend SharePoint application servers, one or more database servers or clusters separating the front-end server tier from the application server. So, allows for better flexibility in service isolation and helps balancing the load across the system. So, as I told, the SharePoint front end will be holding few of the components and the SharePoint backend application server will hold few of the components as described in this image. So, this is the most common architecture and includes many topologies and form sizes. A medium form deployment is useful to serve environments that have the following characteristics: a usage load of up to about 160 page views per second, a data store of 1 or 2 terabytes. The sample medium form that is illustrated in the previous diagram that I showed you provides a fault tolerant SharePoint Server 2013 search form topology that is optimized for a corpus that contains 3,400,000 items. The sample form accommodates 85 page views per second, which is around 306,000 page views per hour, and 100 queries per second, which means 360,000 queries per second. Note that the topology is optimized for physical hardware. However, you can deploy it on the virtual machines also. So moving on to this PPT, to scale out this sample topology to process an additional 28 page views per second, which means somewhere around 113 page views per second or around 406,800 page views per hour, you can add an additional front-end SharePoint server that has a web front-end index component and a query processing component. So with this addition, if you see in this following diagram, so you can scale this particular medium form to have the extension to support the additional page views. So moving on, if the online store is expected to receive more traffic, you may want to change the number of computers on the farm that are running the front-end web server roles with the index component and the query processing component to accommodate that traffic as illustrated in the previous samples. However, each additional front-end server may have less throughput compared to the front-end servers that were already in the environment. Actually, the performance will change depending on how the SharePoint deployment is built. For example, Microsoft ran several performance tests for scaling out the medium form, and the result shows that as the number of computers increased, the complexity of the topology started to overtake the gains. Large form topologies introduces the breakdown of services and solution across multiple forms and additional scaling out of the tiers on a single form. Several SharePoint Server 2013 services can be deployed on a dedicated service form that serves requests from multiple consuming forms. In these large architectures, there are typical web servers, multiple application servers, and multiple SQL Server based servers or SQL Server clusters. Large form topologies serve deployment that have the following characteristics: a usage load in the range of 100 of requests per second, a data set in the range of 10 or more terabytes. In the next lesson, we will talk about the high availability considerations and hardware requirements. For an online store deployment topology with high availability, you must add additional computers to sustain the load if one or more of the front-end web server computers that have the index nodes are not available. An additional computer that is running crawl and content processing components to make sure updates are still reflected in your site when the computer that has the component role is not available. An additional computer that runs with the service applications in distributed cache roles in case the existing computer is not available. A SQL Server topology that continues to serve database queries if one of the database server is not available is mandatory. So this will make you to have a high availability of database. Even if one fails, the other will pick it up, and still you are serving to the consumers. Whoever is connecting to the site will still have the site running and they can view each and everything from the database. So moving on, I will be talking through the hardware requirements. If you look at this slide, so here we have specific requirements of RAM, hard disk and processor for different hardware components, especially for the different search components that are involved with the application server. So if I zoom here, you can see for an index component you may need at least a 48 gigabytes of RAM for each server in the form that hosts an index component, and a minimum hard disk of around 500 GB would be ideal. Further moving on, for an analytics processing component you may need 24 gigabytes for each server in the form that hosts analytics processing component, or a crawl component or a content processing component. So for all the other components, a minimum of 24 gigabytes would be ideal in a large scale setup. So and the hard disk expectation would be around 300 gigabytes, and on request you can add additional hard disks based on the requirements, and processors we may need around 4 cores or 8 cores, preferably 8 cores with a 64-bit of processor. And moving on, so all these crawl component, query processing component and search component would again have the similar RAM of 24 gigabytes like analytics. And on a typical environment, you will be finding you have a SharePoint web front-end server and also application server and database servers, especially in the online store configurations. So here for a processor, it is always preferable to have 8 cores for a medium topology and 4 cores for a small topology with a 64-bit operating system and the processor. When it comes to RAM and hard disk, with RAM it should be 8 gigabytes for small topologies and 16 gigabytes for medium topology, and with hard disk it is preferable to have at least 80 gigabytes for system drive, and for a hard disk space it depends on amount of content. So it differs from scenario to scenario and customer to customer. So in the final lesson in this module, we will further discuss about performance considerations. I will see you there. Performance considerations. When you plan an online store deployment, we need to consider performance. Considering the following factors are very important to improve the performance. First thing would be cache. The query and its results are cached with Windows Server App Fabric in key value pairs, the query being the key and the results being the value. For example, each query there is an approximate of 50% cache ratio. This means that if you have a usage pattern of 200 queries per second, about 100 queries are sent to the search index and the other 100 queries are cached. The results from the cache have lower query latency than those that you retrieve from the search index. For example, results for the home page queries that are frequently ran are likely to be cached continuous crawl. Hence, considering continuous crawl with an interval of 1 minute instead of default interval of 15 minutes. You can only enable continuous crawl on SharePoint content sources. Anonymous queries are cached so that they are cheaper because of lower query latency. Next would be query latency. So query latency is influenced by caching, anonymous access and by other factors such as the number and complexity of the query rules that are applied and triggered. Also consider the characteristics of the storage on which the search index is stored. For example, a disk that has multiple spindles can improve the access speed of the disk and reduce query latency. Moving on, next would be index partition size. So more items in the search index generally means higher latency. Each index partition can contain up to 10 million items. One stores would rarely have more than 10 million items to show. So they only need one partition as in the topology we discussed earlier. You can use more index partitions to either host more than 10 million items or to have smaller and faster index partitions. Number of controls on a page would be the next one to look at. So each control or web part that you add to a page will add some overhead to the server response time for the page. Next would be number of synchronous content search web parts on a page. So avoid using more than 5 synchronous content search web parts on a page while it processes a request for a page. SharePoint Server 2013 executes as many as 5 queries in parallel and returns the results. If more than 5 queries are on a page, SharePoint Server 2013 executes the first 5 queries before it starts to execute the next set of 5 queries. If page requires more than 5 content search web parts, you might run additional content search web parts in asynchronous mode or use query rules and result blocks. Moving on, next would be asynchronous content search web parts mode for slow queries. So a content search web part has an asynchronous mode The query that is associated with the web part is executed after the browser loads the page. Use this mode for slow queries so that the rest of the page appears faster for users. Otherwise, we recommend that you use synchronous queries for best page load times. Next would be number of refiners. A refinement panel web part that has many refiners increases the time to process a query. You can change the number of refiners as and when you want, like we shown in the earlier lessons. We have come to the end of this module. I will see you in the next module review. In this module, we learned about e-commerce deployment and infrastructure architecture. Also, we spoke about head office considerations while deciding on the infrastructure. We looked about online store topology and some samples of it. Also, key guidelines on high availability considerations, hardware requirements and performance considerations while deciding on store deployments. With this, we conclude this module and this course. Next is the final course review on what we learned through this course.